when we have an acute or obtuse triangle and need to find the side lengths or the angle lengths that are not given, we can use the law of sines. And I want you to notice that the law of sines is going to involve a proportion. So if we look at law of sines, it's sine of angle A over side A is equal to sine of angle B over side B. A equals sine of angle C over side C. And we will use two sides and two angles. The law of sines is used when we have the triangle that would look like angle, angle, side given, or angle, side, angle. In triangle ABC, A is 30 degrees, B is 70 degrees, and side A is 8 centimeters. Find the length of C. All right, first of all, what we need to do, we need to draw a picture. Now, this is not a right triangle because we're not given the right angle. So angle A is 30. Let's see. B is 70. We want to find the length of side C. Okay. Now, recall the triangle angle theorem says that the sum of the three angles of a triangle is 180. So if we do 180 minus 100, we get 80. Angle C is 80 degrees. So we're going to find length C, and we can do a ratio of side over angle. So we're going to do C over sine C is equal to A over sine of angle A. Okay, so notice again, the lowercase letters are sides, uppercase letters represent angles. C over sine of 80 is equal to 8 over sine of 30. Okay, so if you multiply each side by sine 80, C is equal to 8.0 over sine of 30 times sine of 80. Okay, and using our calculator, C is approximately 16 centimeters. And we only have two significant digits here. This answer is rounded because if you look at your length, it's 8.0. That's two significant figures. Number 2, find the missing parts of the triangle ABC if angle B is 34 degrees, C is 82 degrees, and side A is 5.6 centimeters. Okay, we know that a triangle has three angles and three sides. So notice you are given two angles, so you're going to find the measure of one angle. We will find the measure of the other two sides. So again, draw your triangle ABC. B is 34. C is 82. We'll find A. Notice what's given is angle, angle. Okay, this side, let's go ahead and mark our A. So if you notice what's given is angle 34. So reading it, we have angle, side, angle. And we know that we can use the law of sines. Let me redraw that triangle again. So before we decide if we have like side, or angle, side, angle, we want to go ahead and put in the information we know. So B is 34, C is 82, angle side length of A is 5.6. We will find angle A. So again, notice starting with angle B, it's angle, side, angle. So again, the three angles of a triangle add up to 180. 82 plus 34 is 116. That's the sum. Subtract it from 180. You get 64. That means measure of angle A is equal to 64 degrees. So you have A over sine of 64. Okay, so we know that A is 5.6. So let me go ahead and fill that in. Is equal to B over sine of 34. All right, so if we cross multiply, or we solve that, B is approximately 3 5/10 centimeters. All right, so let's set up to find side length C. Let's use another color here. So you're going to have, same thing, 5.6 over sine of 64. So again, side length A over sine of A is equal to C over sine of 82. Again, solving the problem, C is approximately 6 2/10 centimeters. So you want to remember to make sure you check the number of significant figures you have and to remember your units. All right, a traffic light weighing 22 pounds is suspended by 2 wires with a tension in the rope 60 degrees with the vertical and tension in rope 2 45 degrees to the vertical. Find the magnitude of tension in wire AB and the magnitude of tension in wire AC. A is the point the traffic light stretches to the horizontal, containing points B and C. So here's what we have. Here's a horizontal here. This is B. This is C. And we're going to hang a traffic light. And we're going to hang them from 2 points here. So it comes down like this. Okay, this is A. And you have the traffic light right here. Okay, so I'm going to represent that by W. So the weight of the traffic light. Okay. Now, the tension in the rope is 60 degrees to the vertical, and the tension in rope 2 is 45 degrees. So this is 45. This is 60. All right, so what we can do is the weight hangs straight down. Let's use some relationships of triangles to draw one triangle so we can use the law of sines. So if I extend this line here, okay, and I'm going to extend the weight down just a little bit more. Now you'll learn that these lines here are vectors that are representing physical quantities. Okay, so if we extend that line here out like this, and we come down here and we form a parallel, a side that's parallel to C. So let's see. So let's say like this. Okay. So, if this is 45, this is 45 by vertical angles. Now, you can see that that makes a vertical line there. So the line adds up to 180. So 180 minus 105 gives us 75. That tells us that this angle in here is 75. But it gives us some other information too. Because this is 45. This is also 60. Because I'm looking at these as parallel lines. And these would be alternate exterior angles. I'm sorry, corresponding angles, the 60 degrees. So this gives us 75 also. So once we know that, I'm going to say that this is T1 and this is T2. So this is T2, this is T1, because these lines here that have represented T1 are parallel. We could form a parallelogram, but we're going to sketch it like this. So we have T1 over sine 45 is equal to 22 over sine of 75. Okay, if we solve that, T1 is approximately 16 pounds. And the proportion T2 over sine of 60 is equal to 22 over sine 75. And T2 is approximately 20 pounds. So we find our answers using the law of sines.